Right, so continuing on, we just finished gas laws. Gas laws finishes a trilogy, which I call the phases of matter trilogy: liquid, solids, and gases. And now we start talking about combinations of those phases. That's what a solution is. It's a combination of those phases. Here's a combination of gas and liquid, which forms a bubble. This is kind of cool. There's even a branch of science called the chaos theory that will try to tell you, which I don't quite get it or believe it, that there is a predictability. This isn't random. All these swirls are not random. There is a branch of science that can predict how these swirls will occur. It's called the chaos theory. I don't understand it. This boy is blowing into a solution. You go, oh, he's blowing into a horn. The horn is made of brass, and brass is a solution. Two targets we're going to cover today. I can describe solution, solute, and solvents, and be able to explain what happens when something dissolves. And number two, I can explain the concept of like dissolves like, give examples, and apply the concept. What is the most important type of substance to life? Is it pure substances like sodium chloride or pure water? No, we are solutions. We're made up of solutions. Solutions. What are solutions? Homogeneous mixtures of two or more substances that are dispersed throughout. To your untrained eyes, you would say, oh, that's just one thing. Just like that brass instrument, you would think, well, that's just made up of one thing, brass. Nope, it's made up of zinc and copper. Homogeneous mixture of two or more substances dispersed in one another. Here are some examples. Yes?
Sorry, since it's based on just what you can see or not, wouldn't it be difficult to draw a hard line as to what's homogeneous and what's not?
Yes. What's homogeneous and what's pure? Yes, based on what you can see. We would need more evidence. Look at it under a microscope. Heat it up, because they're going to have different melting points. Air is a gas dissolved in a gas. We have nitrogen, oxygen, carbon dioxide, methane, dihydrogen sulfide. Natural gas, people think, well, no, that should be just methane. Actually, it would be very dangerous if it was just methane. Why? Well, methane is flammable, combustible, but what's the problem with methane? No. It is completely odorless. So what happens if you have a natural gas leak? You would never know until it's too late. So they add other gases to it in order to give you a chance to sniff it out, to smell it. Vodka in water is liquid dissolved in liquid. Antifreeze is liquid dissolved in water. Okay? Why do they add that funky color? It comes in green, comes in bright red. Yes?
Because that's for alcohol.
Actually, it's more similar to sugar. So dogs and cats will go up to a puddle, and they can't even see in color. So they're like Lenore, go, well, that's kind of weird gray color. All right? And so a cat and a dog will look at it and go, interesting, sniff it and go, sweet. And I'm not saying that it's like cool, I'm saying it's sweet. So they'll start licking it up, and then it'll tear apart their kidneys. I mean, there's no hope. Vets will get in cats and dogs that have drank. By the time the cat and dog is showing symptoms, it's gone. There's no hope for it. So they add the color, not for cats and dogs, because they can't tell anyway. Yeah, it's for humans to make sure that they don't drink this funky green, neon green stuff.
I'm sorry. Dogs blue and green, they can't see red. Cats
Send me the documentation on that. All right. Carbonated water, gas dissolved in liquid. Sugar water, solids dissolved in liquid. Seawater, solids dissolved in liquid. So, what do we call the solids? That which gets dissolved, we call it the solute. And that which does the dissolving is called the solvent. So together, it's called a solution. Solute is dissolved by the solvent. Yes, Marie? No, it can be anything, any combination like you saw there.
How do you know which one is the solid?
The good question. How do you know which one's a solid and which one's a solvent? If they're both solids, whichever one you have the most of. Like steel is made up of 96% iron, 4% carbon. Carbon's a solid. Okay. What does it mean when something dissolves? It's separated. Physically. It's a physical change. It is physically separated. It is dispersed. It's if I came in here and I got Morgan and Molly and Ruth and Allison and Esther and Natalie and Marieli and Marie and got them out. Do I change who they are? No. I just dispersed all the girls. Got all the girls out of here. Why is it that water can dissolve ionic compounds? Does anyone remember?
It's polar.
Maxine.
It's highly polar.
It is not just polar, it's highly polar. It is the granddaddy of all polars. It is polar in the extreme. And ionic compounds are they themselves made up of positive and negative things. Water has a positive and negative side, so water can literally pick it apart. Water can dissolve any ionic solids to a certain extent. Watch.
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules.
Okay, so the positive ions are attracted to the negative part of water. And the negative ions are going to be attracted to the positive part of water. These guys are held together by a strong force called electrostatic. But that ought to tell you how powerful this hydration force of water is, that water can do this. Yes?
Do they like actually take things apart?
Yeah.
So it's not actually.
That's why by heating it up, you speed up the process because you're just simply making water move faster.
To surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
Dissolving and dissociation are the same thing. How are ionic compounds dissolved in water? Individual ions are taken apart by water because water is so polar. Why is it that solutions of ionic compounds can conduct electricity? Okay. I've explained this several times. I'm going to explain it again. In order to conduct electricity, you need to be able to have two attributes. Number one, you need to be made up of positive and or negative particles. Are ionic compounds made up of positive and or negative particles? Yeah. Positive ions, negative ions. And number two, they must be movable. As a crystal, can ionic compounds conduct electricity? Why not? They're made up of positive and negative particles. They can't move. Very good. But what happens if you dissolve them? They can move, so they can conduct electricity. That's why if you've got a pool and a storm comes around, they'll get you out. What if you have a pool of just distilled water? Are you in danger of electrocution?
Not if you're in it. So
The moment you get in it, it's not distilled anymore, and now you can be electrocuted. Okay? What about metals? Are metals, we've seen that ionic compounds will not conduct electricity as a solid. Will metals conduct electricity as a solid? Because what do metals always have flowing on top of them? Electrons. We call it? Nope. We call it? Nope. We call it the sea of electrons. The sea of electrons.
I don't understand how it takes it apart, but it's still salt.
Because you remove the water and the ions will come back together and attract themselves. What other substances can water dissolve? Virtually anything that's like it. So it'll dissolve ionic compounds and what other type of substance? There are 4 types of substances we can talk about. Ionic. What's another type? There are 2 kinds of covalent. What are the 2 kinds of covalent? Covalent means sharing. There are 2 types of sharing. Equal sharing and unequal sharing. What do we call unequal sharing? Polar. What do we call equal sharing? Okay, and what's the other type of substance? Okay, so can water dissolve ionic? Yes, because ionic is made up of positive and negative particles. Can water dissolve metallic? Oh, so the metals, the metal frames, your fences, they all get dissolved away every time it rains. That's a chemical reaction. That's not dissolving. Metals are not made up of positive and negative particles. They do have negative particles flowing on them, but they themselves are not made up of positive and negative particles. Can water dissolve polar? Yes. Can water dissolve nonpolar?
No.
So what other substances can water dissolve? Polar molecules. How are polar molecules dissolved? Well, water has a positive and negative end. Polar molecules have positive and negative ends. It's like getting 2 different magnets to come together. Will they stick? Yeah, they'll stick. They'll form dipole-dipole. Wine, beer, and other mixed drinks are made up of alcohol and water. Why do they mix? Let me show you. Here's an alcohol. What does the alcohol have? The alcohol has a part of it that is symmetrical. That's nonpolar. That is symmetrical. That is nonpolar. That has an oxygen and a hydrogen attached to it. That can demonstrate hydrogen bonding because of it. So, it has a nonpolar side and a very polar end to it. That is where water can attach. So alcohol can be thought of as nonpolar and polar at the same time. Whenever you have an OH on you, you can be dissolved by water. If you have an OH on you, you can be dissolved by water. Let me give you another example. Here's sugar. You're made up of sugars. Sugar dissolves in water. Why? Not only that, but sugar dissolves very well in water. How many connection points does sugar have? Tons. If you have any OHs on you, you can be dissolved in water. All sugars are loaded with OHs. Ethylene glycol, which is antifreeze, loaded with OHs. And it is sweet, that's right. What kind of substance cannot be dissolved by water? Nonpolar. Okay, folks, it's not that water is afraid of oil. Quite simple. What? It would rather be with itself. It's cliquish. It's like Mean Girls, right? They would rather be with themselves. Yes, they wear pink on Wednesday. It's not that it's not that they're afraid of oil. Biology said it was hydrophobic. It's not hydrophobic. It's not afraid of oil. It just would rather stick to itself, and it ignores the oil. It ignores the oil. So water cannot dissolve anything that is nonpolar. Water cannot dissolve anything that is nonpolar. Yes. Yes. Okay, so what is a perfect example of like dissolves like? Polar dissolves polar, nonpolar dissolves nonpolar. Yes, that was the Sharpie in the expo. Okay, by the way, number 2 in your homework that I'm going to give you now, all you have to do is do number 2. No, this isn't it. Look at number 2 once you get this. I ask you, I believe I'm talking. Look at number 2. I ask you, which one would you use to dissolve the following things? Well, you know water can dissolve anything that's polar or ionic. What about paint thinner? What is paint thinner?
It's wood alcohol.
Wood alcohol. Well, okay, well, what's wood alcohol?
It's alcohol.
It is a solvent. What is its job? What is it like to dissolve? No, it cannot dissolve everything. Okay, it dissolves paint. What's so special about paint? When rain falls on your outside walls, does the water begin to run down? Does the paint begin to run off? So what does that tell you about paint? Paint must be... If it's polar, then rainwater will dissolve it. If rainwater cannot dissolve it, then it must be nonpolar. Yes? No, lead used to give us a really brilliant white. So, with number 2, all you have to do is, if you know it can dissolve in water, it's polar. Put down water. If you know it cannot dissolve with water, then you must use paint thinner to do it. Okay, all you have to do is number 1 and number 2 for homework. All right. So, this is an intervention time. This is intervention. This is intervention. Because, all right, Molly came and talked to me. She finally had enough guts to come and talk to me and say, Mr. Moreno, I can't take it anymore. Every time Noah comes into the room, my eyes begin to water. He's a really sweet guy, Mr. Moreno. And you know what it took for Molly to come and admit this. She said, he's such a sweet guy, but he smells really, really bad. So Molly, I called up Noah's mom, and I asked, I'm just kind of beating around the bush, and I go, does Noah take a shower every morning? She goes, yes, he does. I go, does he use soap? She goes, well, I'm not in the shower with him, but I guess. She goes, now wait a second. I remember when he was a little baby, he got soap in his eyes, and ever since then, whenever I would give him a bath, he hated the soap. Then she takes a deep breath, she goes, uh-oh, he's not asked me for soap ever. I bet he's not using soap. Noah, this is an intervention. We love you, Noah. We love you. But the fact is, you're not using soap. And that is what's causing you to smell really, really bad. That is a hand. That is Noah's hand. Noah, listen. The fact is, that your skin is constantly producing oil.
That's nasty.
No, it's not nasty. It's part of it keeps your skin moist. It makes it impervious to water so that you don't start dissolving away, when you're swimming. Okay, the oil is good, Noah. It happens to all of us. We all have oil in our skin. Unfortunately, and I'd like for you to focus. Unfortunately, we're living in an atmosphere of bacteria. So bacteria is constantly falling on our skin, and bacteria love the oil. Now I'm simplifying this a little bit, not too much, but a little bit. But you'll understand the concept. The bacteria loves the oil and will begin to consume the oil, and part of that consumption, that digestion, is poop. So the odor that we're getting from you, Noah, is the odor of bacteria poop, which has a high vapor pressure. So what does it tell you if it has a high vapor pressure? It evaporates fast. And what that means that if it evaporates fast, that means that whatever's holding it together must be very weak. Okay, so here's your problem. Every day you take a shower, oil is non-polar. So some of that water may be able to push the oil off your skin, but probably most of that oil that's accumulated day after day is still there. Okay, yeah, you can look at it if you want. Now, it'll dissolve any salt from your sweating. Yes, it'll dissolve that. But pretty much it's not doing a good job with the oil. So after a couple more hours, the bacteria gets back on there and it starts consuming and it's pooping, and it's bad. It's bad. Okay, what is soap? Soap is a molecule that has a long non-polar tail and a polar head like this. Very polar head. Extremely polar. So soap is non-polar and polar at the same time. So you're going to have to get over the phobia. Just don't do it in your face. Use something else, some other cleaner in your face. Johnson & Johnson. Okay, so if you use soap tomorrow, then what's going to happen, this is a big globule of oil, is that the soap molecule, when you lather, the soap molecule will orient its non-polar end toward you, toward the oil, and completely surround the oil. The action of scrubbing makes these little things. So what happens when he begins to rinse? The H2O sticks to the top part, and it comes off with the oil along with it and goes down the drain. You reduce the amount of oil. It takes longer for the bacteria to accumulate enough for us to begin to smell. And Molly won't be in tears all the time from the smell. You ought to see her. I mean, she's doing this a lot. She's trying her best because she's sweet and she doesn't have the guts to look at you and go, "You smell bad." But I do, because I love you. I care about you. Okay? We all will be happier if you use soap tomorrow. All right? And that is how soap works. Polar dissolves polar, non-polar dissolves non-polar.